topic not really take a long time, but the question is, most of the question refer to spec. That's a bit hard. The slide is not long, but most of the question refer to spec, and it's become quite hard to answer, right? Once we finish this, then you can start, do your homework, right? Because of this question in the repair, take more time to finish, yeah? Okay? So maybe you finish a bit early, but you still have to do your homework, the questions. Okay, got it?
Okay.
All right, where repair? Repair consideration. The first thing to consider, is it worth repairing? If you repair, it costs you maybe $100. If you repair, it costs you $100, example. But if you buy new, change it new, then it costs you $50. So which one are you going to do? Repair or buy new? Buy new is more cheaper. So that meaning by this, the first thing to consider, is it worth repairing? If you repair, it costs you more. So why don't you just remove it and then buy a new one, replace? Yeah, all right. Repair welding can cost up to 10 times of the original cost of making the weld. That if all goes according to the plan. There could be excess issue, contamination issue if it's in service. In service here, example, shutdown of the plant, turnaround of the plant. It's not during initial fabrication. When we do repair in, turnaround or shutdown of the plant, then it's many things, cables, combustible material, many things, contamination. There could be metallurgical issue, changing properties, etc. It may be more cost efficient to replace. You see here, better sometimes replace, do not repair. Yeah? Try to establish reason for defect occurring, as this may determine change to the procedure or retraining. Was it due to the poor fit-ups, misalignment or something? All right. So you can see here, during initial fabrication, the costs are less compared to repair weld. You can see here, all the costs here, where looks like inspector got all the money. Huh? You see all inspector. Okay. So repair consideration here mentioned, can preheat be tolerated? Is it we must refer to original preheat, or we must come up with a new preheat, right, from the repair procedure? Because local preheat welding could lead to distortion and stress. Always when we do weld, always we got something problem with distortion and stress. In service repair, like in shutdown, turnaround plant, more complex because it's related to other things, other items, yeah? Electrical, combustible material. Production repair less complex, like fabrication. Initial fabrication is okay. Approve repair and mark accurately where material must be removed. There is always sometimes problem. The defect on the right side, the production guy repair on the left side. When they do RT or UT again, they've got the same thing there, okay? So investigation, how to do investigation? If defect can be attributed to workmanship, then there is no further investigation. The problem with the welder and fitter, lack of skill, they create a defect, then okay, we know that it's retrain the welder, all right? However, if some form of cracking, all right, it will require further investigation, as a repair may be repeated as the problem may be repeated during repair. How defect detected? By maybe using visual, MPI, PT, but this is applied for surface. This is surface method. And then if you're looking for internal, then we need to use RT or UT to find defect internal. But again, RT and UT also can find internal and surface. But the process not always 100%. Yeah? Sometimes human error or something like that, we miss defect. So defect found on the surface by NDT method like MTPT visual is only for surface and require further investigation using subsurface like RT or UT. Remove defect, investigate further. Internal defect will be found by using UT, RT, and UT able to size. Size here we are talking about length, width, height. Where in RT, it's only got length. Yeah? In RT, we only got length of defect. Normally, we didn't get the depth, the width, right? Okay, so that's the good thing about having UT, yeah, comparing to RT. The process can help determine defect. Subsurface NDT method can helps establish defect type good interpretations. Porosity tend to be central. Slag inclusion and lack of fusion defect tend to be between runs and at the side wall of the original preparation. So example here, we have LOF. So can we use RT? Yes, RT can. UT can. If there is a slack, yes, RT, UT, because this is inside. Yeah, RT, UT is the best. Again, if we have this overlap, then we can use MT or PT, yeah, for overlap. Cannot do with RT or UT. It's surface. Other than this, like all these we can do RT or UT to find this slack. Depend on process, maybe slack, lack of sidewall. Yeah. All right, depending on material, gauging, machining, filing, grinding can be used. Pencil type deburrs for more intricate work. A greater area than just the defect area will have to be removed to allow for access and promote good fusions. If the depth or defect is not known, progressively remove material and NDT check. Example, this is what we have from the cross-section view, and this is from the top view, yeah, the length of the defect. Normally, we need to excavate or grind more than the depth, more than the length, yeah? Like this, right? Possible previously, maybe the crack is up to there, then we need to dig more, excavate more, yeah? To make sure that there is no traces of crack still there. And we can use archive gauging. And the shape of repair are very important. They recommend to use both type. Both type is like this. This is what they recommend. Because that will give access. No problem with the access. Electrode, easy to manipulate. Yeah? But like this, then we have trouble here. Possible there is a treatment of the slack here. All right, treatment of the slack, or maybe lack of fusion. Slack, or maybe lack of fusion can occur at this point because of limited access. Yeah. So both type, this one is more recommended. All right, before welding, what consideration? Preheat. Is it must refer to original WPS or must follow the repair procedure? Distortion problem, right? Material like stainless steel sometimes require purging to avoid root oxidation. Yeah, or root caulking, we call it. Process TIG probably the most versatile, but there may be consumable match issue. All right. And after completion of repair, is it required PWST? Yes. What purpose of PWST? To remove residual stress. After welding, always stress there. Then we need to do PWST. And also need to dress to give same geometry as the rest of the weld. Inspection finish repair, including NDT's original process, and sometimes require pressure testing if required. All right, questions. You are working as a senior welding inspector on high pressure gas supply pipeline. The pipe has a wall thickness 12 mm and certain area 25. The pipe has 24-inch longitudinal, schedule 60 grade, welded with SAW. So that is longitudinal pipe. well, but they weld with circumferential seam here. When the parts there, they weld with 60-10. This is cellulose. Both are cellulose. Cellulose electrode in MMA welding. Okay. Then he said PF position. Okay, that's quite funny a bit, but I don't want to comment about this. In real life, in pipeline project, normally they're using P for this pipeline. Yeah. Pipeline in real life, normally they use PG position, vertical down. But in this question, they're using PF. PG normally they use with cellulose. But I don't want to comment about this. You just follow whatever question they give to you. Okay? All right? All right. Look at question 1. This refers to spec. Question 2, spec. Question 3, spec. Question 4, spec. Question 5, spec. 6, spec. 7, spec. 8, all right, no spec. 9, I think you may not require spec here. 10, I think you may refer to spec. All right, repeat again. 10 spec, 9 no spec, 8 no spec, 7 spec, 6 spec, 5 spec, 4 spec, 3 spec, 2 spec, 1 also spec. All right. Only question, I think 8 or 9, there is no spec. Yeah. All right. I want you to do it straight away after the class. All right. Find the answer. Okay. All right. Look at question 1. So we see it here, you got linear slag, 450 millimeter. And what is the diameter of this? Let me check from this. 24 inch. All right, we got 24 inch here. So the diameter of the pipe, 24 inch. All right. All right, look at 10.4 of the spec. And rewelding here. So rewelding, repair weld shall be limited to 25%. So that's what is said here. All right, then we're going to do some calculations about this. All right. So we have 5. Right, let's say that we have so this is the weld example, and then we have slag somewhere here. We got slag 450 millimeter. And then the diameter of the pipe is 24 inch. Yeah. So now we're going to change this inch to millimeter. So then we times with 25.4 mm. So what we got for, all right, 24 times 25.4. We got roughly 609, or I rounded here. Let's say that's 610 millimeter. So that is the diameter under millimeter. Then then we're going to find the circumferential length of this pipe. What's the length from the circumferential? And what we're going to do is we need to use formula pi d, which is pi is 3.14 times the diameter, which is 610, and then what we got here times 3.14. So we got roughly about 1914 millimeter. All right, circumferential length here now is 1914 millimeter. Then from the spec, they ask about maximum is 25%. All right, then we times with 25% in order to get the maximum allowable in order to do repair. Then we times with 25%. So we got roughly about 478. 478 mm maximum length can be repaired. So if we compare this 478, then what the defect we have? 450. So that is still allowable. Still can do a repair. Yeah, should be no problem. All right. Okay, you may take photo of this because I'm going to discuss from the questions now. All right. All right, look at the questions. So we got maximum. So we got maximum length to repair based on 25% is 478 mm. All right, 478 mm. Then the best answer goes to A, because this defect can be repaired providing welding is conducted in the same condition as the original welding and under constant supervision. The answer B is wrong because exceeding 450 length can't be repaired is wrong. Okay? C, this defect can be welded according to the rules but must be welded using basic type electrode under constant supervision. That's wrong because of based on the length, 25% of the length. So that is what requirement. Yeah. All right, number 2, while witnessing weld repair on circumferential welded joint, the fabricator used preheat 200 degrees C. Would this preheat temperature be correct according to TWS spec? All right, the same section 10.4. So what we see here is say repair weld shall be subjected to the same testing and inspection as original weld with preheat temperature 75 degrees above original. Above original weld preheat temperature. If you got 100 degrees previously, then you for repair you can put another 75 plus another 75 means 175. Previously the WPS says 125. For repair, additional another 75, mean 200 should be okay. All right? So that's what is said here. So the best answer goes to C. Yes, provided the original preheat apply 125. If we plus 75 here, then we got to 200. So that is correct. If previously 200, all right? So the rest all wrong. Yeah? All right, number 3, one of your inspector report to you that a defect has been removed using arc air gauging process. Is it acceptable? All right, we look at the section 10.2 and 10.3. So if you look at in 10.2, removal of defects here. Defect shall be removed by grinding or arc air gauging. When arc air gauging is employed, the resultant removal cavity shall be grounded to clean base metal. And continue here, in the case of partial wear removal, the cut out portion shall be sufficiently deep and long enough to remove entire defect. Then the repair groove shall be inspected by DEPEN or MPI to ensure that defect has been entirely removed. All right. So that statement will give us the answer of Bravo. Yeah, so that's the best one. Okay. All right, number 4, you notice no wear repair procedure has been approved. No wear repair procedure, no procedure. All right, 10.1. Okay, section 10.1, it said, all wear repair shall be conducted according to wear repair procedure. That shall here is mandatory. Yeah. All right, so the best answer goes to C. No, all wear repair shall have an approved procedure. Okay. All right, we move to number 5. One of your inspector report to you that crack has been repaired. Crack has been repaired. All right. All right, look at 6.4. Section 6.4. Under well acceptance level, here, well acceptance level, 6.4, crack not permitted. If crack are found in well, anti-well shall be cut out. Under no circumstances shall well with positively crack be repaired. Okay? So that clearly will give us the answer of alpha. This would not be permitted as crack can't be repaired according to TWI spec. Yeah, right. Number 6, after conducting a repair. What does it mean, this statement? After conducting a repair, means they already done first repair. First repair already done. Now they're going to do second repair. That exceeds the maximum permitted. The fabricator requests approval from you to conduct a repair in this defective area. Right, look at 10.1, section 10.1. A wear may only be repaired once. If the wear still contains unacceptable defect in accordance with this document, the entire wear shall be removed, cut out. Yeah, so that's very clear here. They're only allowed to repair once only, one time. So that's why the best answer here is D. Yeah. Now in this situation, the entire well would have to be removed. 7, one of your welding inspector informed you that wear repair has been conducted without welding inspector. There's nobody witnessed the repair. All right, so 10.1, again, all repair shall be witnessed 100% by qualified welding inspector. Here, all repair shall be witnessed 100% by qualified welding inspector. All right, so that will give us the answer of alpha. Okay? All right, we move to question number 8. You suspect lack of interrun fusion was occurred during welding one of the pipe to pipe. Which of the following NDT best detected? The answer goes to C. Why? Lack of interrun. So lack of interrun is something like this. So that is lack of interrun. Is the same orientation like lamination. This lamination we detect by using 0-degree probe. Because and the sound transmit through is the best orientation to create 90-degree. That's the best. This one is the best orientation using UT 0-degree. And this lack of interrun fusion is the same orientation like lamination. So can we do RT? Sorry. Can we do RT? Cannot. Okay. So what we can do? MTPT? Cannot, because this is subsurface. So what is choice we have? The choice we have here is to ground flush the cap, on flush the cap, and using 0-degree probe. 0-degree probe. And this, the same orientation like lamination, which will give us 90-degree sound to defect. All right, clear about this? If there is a slack, if there is contained with slack, no problem at all. RT, UT, okay. Angle probe, UT, RT, should be no problem because now it's become volumetry. Volumetry doesn't matter, easy to detect. You both UT and RT. Okay, but when it comes to planar crack lamination, always depend on orientation. All right, clear about this? All right, back to your questions. So that's why here, question number 8. UT would be best suited to detect this defect if no slack was present. 0-degree probe, capping remove. All right, so you may write down here, cap remove, capping remove. Scan with 0-degree probe. Yeah, scan with 0-degree probe. Then we're able to detect. Okay, remove capping or flush capping. Scan with 0-degree. All right. All right. Move to question number 9. Some code and standard only permit wear repair to be conducted minimum amount of time before full cutout. What do you think? The best answer goes to A. So I said here, if the wear is repaired an unlimited amount of times, it may affect mechanical and metallurgical properties of the wear. That's the best answer. All right, number 10, one of your welding inspector asks you what is minimum depth where repair excavation need to be. All right, look at 10.3 here. What we got here, the statement here says, in the case of partial wear removal, the cut-out portion shall be sufficiently deep and long enough to remove entire defects. So that is the statement here. All right, so that will give us answer of Bravo, as deep as it required to ensure that defect has been entirely removed. All right. All right, we finished this question and answer for repair, and